Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Today I thought we would shift gears just a little bit and take a look at this TRS-80 Model 100. This was sort of the first laptop type computer that was sold by Radio Shack in the United States, and was actually developed and manufactured by Kyocera in Japan. And I believe they also sold it to NEC, which marketed it in Australia and other places. This has a common problem for these, that when you turn it on, you get nothing other than a bit of a black screen. I don't know if you can see that. We'll zoom in here on it in a second. I've already taken the 4 screws out of the case, which are here, and we'll take a close-up look inside.
This came out way back in 1983 when I was still in high school. Let me tell you, this thing was the cat's pajamas. It was one of the first laptop type computers with a keyboard and LCD screen. It sports an 80C85 8-bit microprocessor, which is a kissing cousin of the 8080 or Z80, and it runs at a blazing 2.5 MHz. The LCD is 8 lines by 40 characters, which seemed humongous at the time. It has a 32K ROM, which contains BASIC and some built-in apps, and it was the last products that Bill Gates actually personally wrote the code for. It also has up to 32K of battery-backed static RAM. That's right, the RAM has a battery backup. This point will be important as we get deep into troubleshooting. It runs off of 4 AA batteries or an external 6-volt center negative power supply. Or you could get accessories such as an external display and disk drive unit or a barcode reader. Enough of that. Let's get started, take this thing apart, and see if we can't fix it.
Okay, here's a bit of a shot with the case opened up, and it's nice that you can kind of flip it open like a book and see both sides at once. See if we can get a little closer here. Notice that the keyboard plugs in here. This is the power LED, I believe, and this is the display cable. Now take a look at this display. This is the number of chips that were needed in 1983 to drive a small dot matrix LED display. That is quite remarkable. Now, after doing some research online, I stumbled across a post from the Vintage Computer Forum. I'll swing over to the computer here. I'll link to this later. One of the things they talked about was quite often bad on these is, here we go, the NiCad memory backup battery right here. So I will test that and we'll see what's going on. And they also mentioned the possibility of some leaking capacitors, so we will take a look at that as well. Alrighty, we've got the case split open here, and I took the keyboard and display side off, and we'll test this battery now. I'll try to keep both my hands out of the way of the meter. That says 4.3 volts, which I think suspiciously might have to do with the fact that I have the batteries in it. The 4 AA's, that is. Well, I see here the memory power's on. I measured the battery a while ago. It was only about 2.5 volts. Evidently, when these go bad, it can prevent thing from booting. You know, see here how it's dropping so rapidly? So it was only being charged up by the fact that the AA's were in there. Okay, one tip here is you'll want to take the batteries out of the battery compartment, and it looks like we need to slip the DC input jack up like so. And everything else looks like it should slip up from the top like this. Okay, looks like there were 5 screws in total, 3 across the top, and 2 here in the center bottom. Oh, no, here's another one right here. 6 total. 3 on the bottom, 3 on the top. And they are all the same length. That makes it nice. Double check here. Oh, you know what? I bet this screw here has to come out as well. It's got some type of little rubber bumper there. Yep. Ah, that green wire unplugs from here, tricked by these 2 tantalum capacitors. Looks like it's above R150. Okay, let's see what happens now. We can get this thing out of here. So gotta have the batteries out because these 2 springs need to slip out here. Okay, and there are some plastic spacers here, or rubber. Huh, it looks like a couple of them are missing here, that's odd. Oh, I see. This shield goes down and these little rubber bits here just go there to hold it down. It still means this could flip up and touch the bottom of the board because we're missing 2 of those rubber deals, so we'll have to find something to replace that. Now that capacitor is right here. It looks like C85, and that does look rather crusty underneath there. And here's our battery. So measure the battery again to see if it's dropped. Yeah, it's dropping with just the load of the meter on there. So my suspicion is the battery's not any good, so we'll go ahead and pull it out. Handy desoldering gun. When you're desoldering this old stuff, you don't quite get it the first time. So you can apply some fresh solder. Let your reflow better. It's got a little influx in it. That one's being cantankerous. Okay, sorry for the shakiness. I'm zoomed way in and trying to do a macro shot here. Take a look at the white crusties underneath this capacitor right here. Okay, this is the right hand side of the circuit board. You can see where I removed C85. It was indeed a little crusty under there, and it just started leaking, and I cleaned that up. And I also removed a pair on the top right hand side C82, which had also just started to leak and was a little crusty. And I've looked at the rest of the electrolytics, and they all look fine. Oh, I just spotted another one of that same type. Huh. Made a liar out of me. Okay, all of these little black electrolytics here, going over toward the left hand side of the board, are also just starting to leak. It's funny, all these little black ones are the only ones that are leaking, and they're all made by the same company. So the rest of them look okay. So I'm going to pull out these four and then scrounge around to see if I have any replacements that'll work. Just a tip here, you see I've marked where the capacitors are. There's just two right there, and I think the last one's right there. Just marked them with the black dot on the back of the board so I know where they are. I held the board up to a light so I could see through and mark it. I got the other four capacitors removed, and this was right here the worst of the damage. It didn't really eat anything, any of the copper, but it did get some of the solder mask on here. Here's two more of them. And the last one, and I'll try to come out here so you can, in relation to the board, so you can kind of see right here. We go here, 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 and then we have the two over here. All four of these little ones were 10 microfarad, 16 volt, and as luck would have it, I've got some of those on hand, which I misordered quite a while ago. I ordered the wrong package size, but I've got those. And the other two over here, I found some suitable replacements in my junk drawer, so I'll solder those in. I had a devil of a time unsoldering these little capacitors. One hole was fine and one hole was not. And then I realized that one hole is going into the ground plane. So you can see that here and here. And just couldn't heat up that whole ground plane just traveling through that little via and lead. So what I wound up doing was using a small heat gun. It doesn't need to be very hot, and I preheated the board in that area. I applied a little more solder and as I mentioned, the negative lead of these capacitors is going to a big ground plane, so we need to preheat the board some. I just got a small heat gun. You don't want to use a big heat gun that's going to get really hot and melt things. So I'm going to turn this on, which will be a little noisy, and I'm going to preheat this area of the board and then solder it. I'll let my iron stay on there for a few extra seconds to make sure we're getting the heat all the way through to the other side of the board. And I also put a little extra flux when we use to help things out. Okay. Now we'll look at the other side of the board. That looks fine, so I'll trim these leads and I'll do the other two capacitors in a similar manner. It's now been a couple days since I started working on this Radio Shack Model 100, and I just got back to it after several chats with the nice folks on the M100 mailing list, which I will link into below. I've got it kind of folded open like a book here to make it easier to work on with the batteries, because I don't have a 6 volt center positive, or excuse me, center negative power adapter handy. At any rate, I replaced 5 or 6 of the capacitors little electrolytic capacitors that have been leaking. A few of those were in the power supply section. Replacing those brought back all 3 voltage rails. There are 2 plus 5 and 1 minus 5. It still does not function. After some more poking around, I found out it was not actually starting up each time. There would be some brief activity on the address and data bus, and then it would die. Sometimes it would stay running. So tonight I'm going back and checking each line on the microprocessor, which is an ADC85, for activity. I will focus you in on the oscilloscope, and while I'm probing the pins, and I'll tell you what pin I'm probing. Here I am on pin 22, which is, if I get back to my pin out here, pin 22 is address 8. Oops, let's not short out the pins there, Jeffrey. Okay, address, the 8085 is a little different than the 6502, which is used in the Commodore 64, Apple, etc. The lower bits of the address bus, 0 through 7, and the data bus are multiplexed, so there's some other chips that separate those later on. The higher 8 bits of the address bus are not. So here we're on bit 8 of the data bus, and let me put this single shot mode so we can get a better idea. So here in single shot mode, you can see that we've got some pretty nice looking square waves here. What the data is, we don't really care about at this point. I'll take it out of single shot, and we'll go on address and data bit 7. You notice this looks a little funky right in through here, so let's put it back in. Oops, I let off the pin again. Okay. Here we go. Alright, we'll put it back in single shot mode. Take a look at this nonsense. What in the world is going on here? Every once in a while we're not rising all the way back to 5 volts. We've got kind of a slope there which looks suspiciously like some sort of RC curve. That is really, really bizarre. Okay, here is the test setup. It's about a week since I've started, and I've spent a few hours on this and gotten basically nowhere after replacing the leaky capacitors. I have a chip clip on M2, which is an address or data latch actually in this application. I'm powering the board with my bench power supply, 6 volts. And I printed out a copy of the schematic. We've got that here. And all those wires you saw were for a logic analyzer, which you can see here. I'll change the settings on the camera and we'll look a little closer. Actually,
The logic analyzer was set up to monitor data bits 0 through 6. And on the 8th channel of the logic analyzer, I had that connected to the not read signal, so I could use that as a clock, because the logic analyzer software has a simple parallel decoder set up in it. So after some experimentation, I found out if I set the capture speed to 8 megahertz and set it to decode on the rising edge of the clock, it did a fairly good job. It's not perfect. What would have been better is to be able to set a delay between the clock signal transition and when it decoded what data was there. I did contact Saleae, and actually they were very responsive, and one of their engineers emailed me and said, well, it couldn't do that as it was, but that the source code for the simple parallel decoder was part of the software development kit, which was a free download. But I got this to work well enough I didn't need to delve into yet another project trying to write my own plug-in. At any rate, so what the simple parallel decoder does, as I said before, is at each clock transition, which is here, 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 you can see all the dots going up the data. So for each clock transition, it figures out what data is there and creates a list of that for us. Now, since we don't have bit 7 of the data bus, it requires some interpolation to figure out what that should be. So I saved this, what I captured, and decoded as a text file, and brought that into Visual Studio here. And I have that on the left. This first column here is just the timestamp. In the second column is the data at that timestamp. And somebody was nice enough at some point in time to do a ROM dump of the Model 100 ROM and annotate the whole thing, which was invaluable for figuring out what it was doing. So going between what I got out of the Logic Analyzer software and the annotated ROM dump, I was able to kind of walk all the way through and see what was happening. So the way the data was captured, I was not only getting what was being read from ROM, but also what was being read from RAM. When I first did this on a normal boot, it got to the section of code where it expected to run a snippet of code that was in that battery-backed RAM, and that's the point where it went haywire. So then I did another capture where I was holding the control reset down, which does a cold boot, and it did go into the cold boot routine, and it got to this section right here where it copies the data from ROM to RAM, and that's 143 bytes, and it goes through here. I won't bore you with all the sections where it's copying that, but it does all that copying, and it gets down to here, and right in here this should be a return. So it jumped to this section of code, and it should be doing a return. So we should be reading back from the RAM. We should be reading the return address, and we're reading from the stack area of the RAM, which should have the return address on it. Only the return address wasn't there. Since we were copying to RAM, it seemed like we were probably copying over top of the stack, which shouldn't happen. They're in different address spaces that don't overlap. One of the fellows on the Model 100 mailing list said, you know, if internally in that RAM chip the address, one of the address lines was stuck, they could in fact overlap, and until you were trying to write into that RAM separately from the stack reading and writing, you would never notice it. And you know, that seemed like it was probably the case.
We're to the point where I need to start desoldering some components from this board. Before I do, I want to give it a good cleaning. The whole board is covered with a nasty flux. This yellow rag here was just all the flux off the back. And I'm going to do the front now, and I'll cut in some close-up shots here. So I'm going to use the denatured alcohol in a cup with a brush and tip the board up on edge like this and just flush it down, and follow that up with some of the electronics cleaner, and then make sure I squirt in the switches really good here, and so there's no residue in here, because this flux does leave a residue unless you get it all off of there. let's get started with it. So hopefully this is in frame. It's going to give you an idea of what I'm going to do here. I can already tell that the front wasn't nearly as bad as the back because there's not as much yellow ooze that's dripped down on the rag here. I'll work on it a little more here and then I'll spray it off with the other contact cleaner. Well, that got rid of a good deal of the schmaltz that was on the board. And the areas I couldn't get to with the toothbrush, like over here and in here, it's still a little dirty. So after I desolder this RAM module here and do some more testing and finally get it fixed hopefully, then we'll give it another good clean. For now, let's get this guy out of there. It is rather close to this socket, so I'm going to have to be careful. This would be a good place to use some cap tan tape, but I don't have any. So I'll use what I do have. On these pins here. On these older boards, a lot of times it really helps to get a little fresh flux and solder on what you're desoldering, which seems counterintuitive, but it does help it flow out much better. Trick when you're using a desoldering tool like this. I bet I had that roll of solder right here. Sorry about that. One tip when you're using a soldering tool like this is you're not getting too big a hurry. You need to leave it on there long enough to heat up the solder on both sides of the board so it gets nice and fluid, and then pull it off. Use a slight wiggling motion without really putting any force down on the board. We don't want to scrape the trace off. Keep the tip clean. There's a few of these tracks that are on the power bus. There's a lot of copper there, and it's hard to get them heated up. So I'm going to re-hit the one or two I tried to desolder here with solder, and then we'll preheat that section of the board with the heat gun. This before. This is my little heat gun I normally use for heat shrink tubing, but it works good for preheating like this too. About hot enough now it's uncomfortable to touch. about it. If you don't happen to have a heat gun, you can use a hair dryer for that too. You don't want to use a big heat gun. She can very quickly catch your board on fire that way and they get way too hot. I'll try to wiggle all the pins now. That side of the chip seems loose. So, yeah. Don't know if you can see that, but it just about drops itself on through there. So, flip it over. Wiggle that guy loose. This is some type of ceramic board that has the traces routed on the inside. It's got 4 2K static RAM chips mounted to it. Now I want to socket that. And one problem is, and we can see it here, that these dip modules for these RAMs are wider than a standard socket. So this is 0.6 and this is 0.7. So I'm going to take a standard socket like this, or actually one with enough pins. This one's a little short. Take a standard socket and cut it in half and put it in there, because I don't have any of these machine pin sockets like this. Okay, I took a 30 pin socket and cut it in half. I've got it oriented here on the board in kind of the standard orientation it would be if it had the middle part in there. In other words, the outsides are slightly taller, so those are still like that. I'll hold that in place and flip it over. And then I'm going to take one pin had been out, and the next pin had been in. We'll do the same thing on both ends. Just a little, we don't have to go crazy and bend it all the way over here. And that'll just help us hold this in place. Now, they're not going to fall off of there. And of course, you know me, just a tiny bit of flux on each pin. What we're going to do is just take one pin on each side. It's going to be easy to solder. Go ahead and hit that guy. Stand our board up so we can get our finger underneath it. And kind of eyeball that and see if it looks straight. Okay. Got our split in two socket in there, and I've installed a different RAM module, not the one we pulled out. The module that got pulled out, if you can see it there, I put a black dot on it so I would not get it confused. So I don't know if that's good. I'm going to put it in a static bag. And I've got this set up here with my bench power supply, which will turn on. It is set to 6 volts. And turn the output of the power supply on. And I'm holding down control brake while I'm turning the power switch on. And nothing different. Well, I realize you can't see the LCD, but it's the same. It looks like it wasn't the RAM module. Well, that's disappointing. The other thing it might be is M3 or M4, which are the decoders for the RAM. The M5 also plays somewhat of a part in that. So I think we'll go ahead and get the logic analyzer on here though, and oh hey, you know what? I didn't put the ROM back in. That would help, wouldn't it? What did I do with the ROM? Here we go. Yep, it's not going to work without that bad boy in there. Our output's off. She's in there. Okay. Power switch is off. Power supply on. Control brake down. Power switch on. And hot damn. See if I can hold this up here so you can see what is going on. I don't know if you can see that. Maybe I'll get it here where you can. We got a screen on there. So what we had was a bad RAM module. That was a lot of work to diagnose, let me tell you. Well, now that we have it running, it's time to do a full recap and get rid of all those old nasty electrolytic capacitors, just so we don't have to worry about that again. Another thing I want to get rid of for good is that NiCad backup battery. NiCads are kind of, well, they're out of favor anymore. There's better choices. One choice would be nickel metal hydride, but I'm going to try a super capacitor. I've done some calculating and figured out that about 2.5 farad super capacitor ought to do about the same job as the original NiCad did. So I've ordered one of those and we'll get that put in there and see how it works. Another thing I want to do is give a little squirt of contact cleaner that has some dry lubricant in it into the switches. This will help keep them lubricated and working good for years to come. Oh, I briefly mentioned that the Model 100s, the early ones at least, have a non-standard pinout to the RAM. These were made by Sharp, and kind of like some other things back in the day, standards really hadn't been adopted all over, so it was just a little different. This means you can't read it in a normal EEPROM programmer, and you can't burn a normal EEPROM and plug it in there to correct for things like the Y2K bug. So I designed a little adapter which will let it go either way. I'm not sure if the height will be too much to fit inside the case though, so it's something that I'll have to try and see. I lost one of my additional RAM modules because the first one went bad, so I'm going to have to see about making some additional RAM modules. Unfortunately, some other folks have already figured this out. They've got their board files up at OHS Park, so that should be a possibility to make some more RAM modules. So stay tuned for part 2. And we'll look at all this stuff, do the recap, put that super cap on there for the memory backup, and see about, you know, how to transfer files and programs and things to the Model 100. Thanks. Oh, and if you like what you see, tell your friends, tell your neighbors, tell your mom, click on the subscribe button, click on the like button, click on the little bell icon, which will let you know when I post a new video. Thanks, and we'll see you later.